Lesson 63, homework. We are looking at number 1 through 3. We're going to simplify here. Number 1, we've got the square root of 256. Now, let's go ahead and factor this the way I normally would here. I know this is divisible by 2 because it's even. So that's 128 and 2 times 64. Now I know 64 is 8 times 8. So I've got 2 2's and 2 8's. 2 gets to come out, 8 gets to come out. 2 times 8 is 16. So the square root of 256 is 16. Number 2, square root of 108. Now 108 is 2 times 54, and 54 is, let's do 2 again, 2 and 27, and then we've got 3 and 9 is 3 times 3. I've got 2 2's, I've got 2 3's, and I've got 1 3 left over. So I've got 2 times 3, those guys get to come out, and what's left over inside the radical is 3. 2 times 3 is 6. 6 square root of 3 is the answer there for that. Number 3, square root of 294. Excuse me. Square root of 294. Again, this is even, so I know I can cut this in half, and that gives me, what's 294 divided by 2? 147. Let's double check. 294 divided by 2, 147. Now 147, let's see, that one is divisible by 7, right? Divided by 7. Yeah, 21. So 7 and 21 gets 147, and 7 and 3 make 21. So I've got 2 7's that get to come out, and 3 and 2 have to stay in. So I've got 7 outside of the radical, and then I've got 2 times 3 inside the radical. 7 square root of 6 is the simplified form of the square root of 294. Number 8 is our next problem that we're going to be working on. Find the least common multiple of 2t cubed s v to the 5th, 6v cubed t to the 4th, and 10v to the 8th s to the 4th. Alright, least common multiple here. So I'm going to look at the 10 first, and I'm going to say 10 plus 10 is 20, and 2 goes into 20 but 6 doesn't, and then I add another 10, that gives me 30. So I know that 6 goes into 30, and 2 goes into 30, and 10 goes into 30. So my least common multiple starts with a 30, and then the variables are much easier here. I've just got t to the 3rd, t to the 4th, and I don't have any t's here. So t to the 4th is my greatest common multiple here. And let's put these in order. Let's do STV. So I'm going to do my s's right here, s to the 1 and s to the 4th. So s to the 4th is my least common multiple here for the s part of this. And t we already said was to the 4th. And then v, the greatest one here, v to the 5th, v to the 3rd, v to the 8th, v to the 8th. And so that's how we do that one. And then number 9, least common multiple of 14 dv to the 3rd, 7 s squared v and 28, s to the 7th, and v to the 5th. Alright, so our numbers here are going to be a little more straightforward than the last one. Here's 28, 7 goes into 28, 14 goes into 28, so my least common multiple here when I'm looking just at the coefficient is 28. And then let's do our d value next. And I've got d to the first power here, and I don't have any other d's, so I'm just going to leave it like that. And then I'll do s next. I've got no s's here, s squared and s to the 7th. S to the 7th is my greatest common multiple. I'm sorry, my least common multiple. Did I say greatest on the last one too? Oops. And then v, I've got v to the 3rd, v to the 1st, v to the 5th. V to the 5th is my least common multiple. So your term here should look like this. And then we have number 10. Which of the following polynomials equals this? Alright, so we can do number 10 right here. I've got x plus 5, x minus 5. This is a difference of squares, and so it's multiple choice in the book. But when I have a difference of squares, I have the same binomials, except for one is plus and one is minus. Otherwise, they're exactly the same. And so all I do is I square the one on the left, that's x squared. I square the one on the right, that's 25. 5 times 5 is 25. And then I put a minus between those two. There it is, x squared minus 25. Let's look at number 12. Number 12, solve by substitution. I've got 6x minus 2y equals 12. I got y equals negative 5x plus 10. Now I'm going to take what y equals, which is negative 5x plus 10, and I'm going to plug that in there. I'm going to substitute that for y. 6x minus 2 times negative 5x plus 10 equals 12. I distribute my negative 2. 6x plus 10x minus 20 equals 12. I'm going to combine my like terms, and I'm going to add 20 to both sides. 6x plus 10x is 16x. 20 plus 12 is 32. Divide both sides by 16 so that I have 1x on the left and x equals 2. Now I'm not done yet. I have found the x value of my solution, which is where these two lines cross, and that is 2. I need my y value now. I'm going to plug this x value into this equation. I could plug it into either one, but I just plug it into the one that I think is going to be the easiest. I plug in 2 for x. That gives me y equals negative 10 plus 10. Negative 10 plus 10 is 0. My solution is 2, 0. Next, I've got number 13. Number 13, solve by elimination. 6x plus 4y equals 22. And I've got negative 6x plus 2y equals negative 16. They were very nice in how they set this up to give me just these two 6x's that to just go away. Add these guys together. That becomes 0. This becomes 6y. And on the right here, we've got 6. 22 minus 16 is 6. Divide both sides by 6, and y equals 6 divided by 6, which is 1. Now remember, that's just the y value of my solution. It's not the whole thing. I need my x value. I put my y value in the x spot. There we go. Now let's find our x value. And let's plug this y value into the top one. How about that? 6x plus 4 times 1. I've taken my y value, plugged it in for my y value here, equals 22. 6x x plus 4 equals 22. Subtract 4 from both sides. 6x equals 18. Divide both sides by 6. Y equals 3. 3, 1 is your solution. That's where these two lines cross. Number 14. Solve the system of linear equations by graphing. Answer with a graphing calculator. Or check your answer with a graphing calculator. I don't have a I do have a graphing calculator right here. I'm not going to use it though. Negative x plus y equals 4 and 2x plus y equals 1. Now, before I put these on a graph, I am going to write these in slope-intercept form because I feel like it. I'm going to add x to both sides of this equation on the top. That gives me y equals x plus 4. That's a lot easier for me to graph. Y equals x plus 4. And this next one, I'm going to subtract 2x from both sides. That gives me y equals negative 2x plus 1. Now, I'm graphing these, and it would be nice if I grabbed, a magic piece of graph paper that I have lying around, but I don't. So we're going to have to just be really clean and neat with how we graph. Let's graph this first one. I go up to 4. 1, 2, 3, 4. I put a point right there. When x is 0, y is 4. My slope is 1 over 1, so I go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. There's my line right there. Now, I'm not sure where these are going to meet yet. Let's see. Oh, they're going to meet back here somewhere. All right, so for this next one, I go up 1. When x is 0, y is 1. I'm going to label this one, the first one, first line. And now here's my second line. My slope is negative 2 over 1, down 2 to the right 1, or up 2 to the left 1. That's what we're going to have to do to be able to get onto this line. Up 2 to the right 1, up 2 to the right 1. Now let's see if we've found this spot right here in actuality. We went down 1 to the left, went down from 4, so that gives me 3. Is that point here. Let's see here. If that's the right point. Are we right there? I think we are right. Yeah, negative 1, 3. So we went down 1 to the left 1. That gave us negative 1, 3 from the top. And then we went from 1, we went up 2 to the left 1. So that got us up to 3 for our y value and to negative 1 for our x value. So that is our point right there. If we would have done this on some graph paper, we would have seen that really easily and nicely. Next time. Number 15. City planning. The city hall wants to build a rectangular walking track around the town's park. Below is a sketch of the new park. Let's draw this park real quick. So we've got a rectangle, 2x on the right, 3 times x minus 2 on the bottom. Write the polynomial expression for the perimeter of the rectangle. Simplify the polynomial. So remember, perimeter is just all of the sides added together. And you can write it in a couple different ways. You can do 2x times 2 and 3 times x minus 2 times 2 if you wanted. Or you could just lay them all out, because this is going to be 2x and this is 3 times x minus 2 here as well. So we could just add them all together, and that might be a little bit cleaner or easier to see what we're doing. I've got 2x plus 2x, so those sides are done. Plus, now let's distribute this 3 into this binomial here. So I've got 3x minus 6. 3 times x is 3x, 3 times negative 2 is negative 6. So I've got 3x minus 6 plus 3x minus 6. So I need this side and this side as well. We're just adding 1, 2, 3, 4 sides together. Now let's combine like terms. I've got 2x plus 2x plus 3x plus 3x. So that's 4x plus 6x, that's 10x. I've taken care of those like terms. And now negative 6 and negative 6 is negative 12. 10x minus 12 is the perimeter of this rectangle. We're going to move on to number 16 now. Which ordered pair is the solution of the system of equations? Oh goodness, all right. Here is the system of equations. We've got 9x minus 3y equals 20, and we've got 3x plus 6y equals 2. Now, one thing we could do is we could plug in each of these options here, A, B, C, and D. Those are options for the multiple choice here. Or we can just find the solution ourselves and then see which one fits. And that's what we're going to do. What I'm going to do is I'm going to multiply the top by 2 so that I can eliminate these y values here. That gives me 18x minus 6y equals 40 over 3x plus 6y equals 2. Now, once I've done that, I'm going to now eliminate those y's. 18 plus 3x is 21x equals 42. Divide both sides by 21. X equals 2. So that's the x value of our equation, of our solution. And unfortunately, B and C both have the x value of 2. Otherwise, we could have just been done if only one of them had an x value of 2. So let's just plug in this value of 2 for x. Let's plug that into this one. This one looks like it's going to be a little bit easier equation. So 3 times 2 plus 6y equals 2. 3 times 2 is 6 plus 6y equals 2. Subtract 6 from both sides. That gives me 6y equals negative 4. Divide both sides by 6. Y equals negative 4 6. I divide the top and the bottom both by 2 to get negative 2/3. So that's my y value, negative 2/3. And in the book, that selection is C, or that option is C in the book. Now we're going to go on to number 18. 18 has A, and B here. A group of 30 white-tailed deer all had 2 antler points at 1.5 years. At 4.5 years, their points were counted again. Now we're going to make a box and whisker plot of the set of the data in the graph. Can you predict how many points? Okay, number 18A. We've got number of points at 4.5 years. 4.5 years. And we've got number of deer. And I've got 2, 1, and 3, 0, and 4, 4, 5, 3, 6, 7, 7, 4, 8, 10, and 9, 1. Alright, make a box and whisker plot. Alright, so we should have a line like so. And let's start with 0 here, and let's go all the way to 10. 1, 2, 3, 4, 5, 6, 7. I'm going to move that 5 over a little bit. 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now we are going to put a dot over the 9 here because that's that represents that 9 right here in the 4.5 years number of points on the points at 4.5 years. Okay, so we have a point there at 9, and then we have also a point here at 2. All right. Now we are going to have a point at 6.5. And that's because let's see, wait, where is that? We have a point here at 6.5. Yep. And that is that middle of the box part. And then we have a point at 8 and a point at 5. And that makes up our box. And then we have a line here for our whiskers here like so. And we have done our box and whisker plot. Yep. All right. Then and 8, that was A, is construct your box and whisker plot. And then B is, can you predict how many points a deer would have at 4.5 years old if you know that it had 2 points at 1.5 years? Now, that's kind of a tricky question. The answer is no, because we don't have, there is a wide range on this graph. Like, there's no clear data that would suggest that you could figure that out. So the answer here in the book is there is a wide range on this graph. Yeah, it's not a linear deal here. All right, number 19. 19. Main Market Square in Krakow, Poland, has an area of 40,000 meters squared. Find the length of one side of the square. So this is a square. And a square, the area of a square is side squared, or length times width, knowing that the length and width are the same. So all I have to do is take this 40,000, set it equal to s squared, take the square root of both sides, and that gives me 200 meters. 200 times 200 is 40,000. Number 20. A football field's dimensions can be represented with the width of, let's draw the football field. The width of 3x plus 15 feet. And a length of x plus 10 feet. And these maybe should be switched when we talk about width and length, but it doesn't totally matter. We are just following the area. They're asking for the area. So the area is length times width. Doesn't matter what order they're in because you're just multiplying them. So the area of this football field is x plus 10 times 3x plus 15. Or 3x plus 15 times x plus 10. And they want this to be multiplied out. So let's use FOIL to multiply those out. First is x times 3x, that's 3x squared. And then let's do the outside. X times 15 is 15x. And the inside, 10 times 3x is 30x. I put equals here, that should be plus. And then 10 times 15 is 150. I combine my like terms. 3x squared plus, oh, I said 30, but I wrote 3. Yep, is 45x plus 150. And that is feet squared, or square feet. Number 21. Find the missing number. Okay, my original price is $1,527, and I've got a 38% decrease. And we want the new price. So what we're going to do here for this one, we're going to set up a proportion. I'm going to put the original on the bottom. I'm going to put 100% on the bottom. And then a 38% decrease, I'm going to subtract 38 from 100. And that gives me 62. So I'm going to put 62 on the top. And then I'm going to solve for what my new price is going to be. I'm going to multiply, I'm going to cross multiply. 62 times 1527 is 94,674. Divide both sides by 100. And that gives me 946.74. And dollars. That's my new price. Number 22 is the next one. Same kind of idea. I've got my original price, which is 25,720. And I have a 1.5% increase. 1.5% increase. Now, a fancy way to do this is just divide this by 2 and then add it to the original. No, that won't work. Don't do that. I'm just kidding. Let's set up a proportion and not be fancy at all. Put the original on the bottom next to 100. 1.5% increase, so I've got 101.5. I added that 1.5 to the 100, and I didn't do something fancy that was going to make a big mess and get us the wrong answer. Then I cross multiply. 100x equals 25,720 times 101.5 equals 261,0580. Divide both sides by 100. Pop, pop. And that gives us x equals, divide by 100, 261,0580. And that's dollars. $26,105.80. And number 23. Another one of these. Original price is $10.25. And I've got a 215% increase. 215% increase. I'm going to do my proportion just like I did with all these other ones. I'm going to put my original and I'm going to put 100. I'm going to add 215 to 100. That gives me 315. And then I'm going to put x up here. I'm going to cross multiply. I've got 100x equals 315 times 1025. 3,228.75. Divide both sides by 100. X equals $32.20. Let's see, does it say to round? Yeah, we'll just round here to the nearest penny. So it would be 28.75, but that 7 is going to make that 8. We're going to round that to a 9. So $32.29. That's number 23. Number 27. Two students used the stem and leaf plot to find the mode height of the basketball players of their school. Which student is correct? Explain their error. So we've got this plot here. The student A says the mode is 185 centimeters, and student B says the mode is 170 centimeters. Do we need to write this whole plot out?